recording, because I forget otherwise. And I will formally welcome everybody to this webinar from Sam Pazicni from the University of New Hampshire. Many of you in the audience will know Sam, obviously. He's a well-known chemistry educator. Sam's a bit of a polymath, I think, because he's an inorganic chemist. He's a chemistry education researcher. He's a professional performer. So I'll see, maybe we'll see all aspects of this this evening, Sam. So we're looking forward to it. As you will know, he's interested in a whole range of different chemistry education research activities. Well, certainly many people I know have come across his work and the Dunning-Kruger effect and very well-cited work in that area. But we're all here to listen to him talk about textbooks and all things textbooks. I can promise you a really interesting presentation. So the audience members, hello to everybody. You'll see in the bottom of your screen there's a purple arrow. And if you click on that purple arrow, it'll expand out a side menu. And there's a chat button in that side menu. And this is where you'll be able to interact with the presentation. So as Sam is giving his webinar, just feel free to type in any questions or comments or thoughts there. And we'll stop about a third halfway through, and then again at the end. So I will relay any questions to Sam or any discussion comments that come up. So that'll be the way we kind of have the interaction in the webinar. So feel free to type in questions as they come along. I will stop talking, and Sam, pass over to you. Thank you very much for your webinar, and we're really looking forward to hearing you present.
Oh, thanks so much, Michael, for that kind introduction. I'll start with an apology to everyone listening. It is spring here in the New England region of the United States, and allergies are really bothering me. And so if I sneeze or cough or take a drink of water, please do forgive me. And so, as Michael said, I thought that some research strands that we have going in our research group fit nicely around the theme of commenting on something that we all interact with almost every day, and our students might also as well, and that would be the textbook. And so hopefully what I have to say will stimulate some good conversation about that. But to start, I would like to draw some analogy, if I can advance the slide. Maybe I can't.
So it should be an arrow on the bottom of the screen. Is it going to the next slide? No.
Oh, there it goes.
There you go.
Oh, well, excuse me. And so I do have to thank the people who did most of this work, which is my two former graduate students, Dr. Dan Pyburn and Dr. Renee Buell. I miss them terribly. They were wonderful students, but now they are wonderful professionals in their own right. And so to begin, I'd like to draw an analogy with regard to the limitations of research. Oftentimes in the laboratory, as Michael said, I am an inorganic chemist by training, we have particular words that we use to sort of signify that what we're doing or what we're saying has a limitation to it. And just with a simple Latin phrase, we automatically know what that means and what those limitations are. And so, for example, when we study organisms or biological molecules outside their natural milieu, I did this for my graduate work, actually. I did a lot of protein biochemistry in buffer solutions. We call that in vitro. It's Latin for in the glass. And automatically we know that, for example, the plant that this researcher is holding in this picture is not coming in contact with the microorganisms that might surround its roots or soil that might have any resemblance to what happens in nature. It's a very controlled environment, and we know the limitations of that. My next example is something that, again, I worked with in graduate school quite a bit, which is a Schlenk line. And we know that when the word or phrase in vacuo is used, we take that as that these substances are going to be either sensitive to air or moisture or both. And so if a molecule is made and we want to think about particular applications for it, it being stored in vacuo does mean something that we have to consider. My third example is when we gain insight into chemistry via modeling or computation. Oftentimes the phrase in silico is used. so that we understand that the results that we're looking at were not produced in a laboratory. They were produced with particular limitations of computer modeling. And so we have all of these wonderful phrases that capture a lot of these ideas in laboratory research, and I haven't really come across any in chemistry education research, but I can think of at least one, which is when we do research in classrooms like I have pictured here, and we make a grand assumption that the only learning that might be occurring as a result of our classroom pedagogy or our interventions that we may be pursuing as research, that the only effects are going to be those that are happening there in that classroom. And to have a little bit of fun here, I would like to call this incubiculum, which is Latin for in the room, because I think we have a tendency as chemistry education researchers to really only believe that what we're doing happens in the room, whereas we tend to ignore factors that might be occurring out of the room, and I don't know the Latin phrase for that. And so, indeed, one of the reasons why my group is so interested in studying textbooks and learners interacting with them is that, quite frankly, students do not spend that much time in our classrooms. And so, for example, here at the University of New Hampshire, most of our classes are approximately 3 hours a week for 15 weeks, and so that's 45 contact hours that students will have in a class of mine. In the span of 15 weeks, however, there's approximately 2,500 hours that students could be doing something. And so the time in my classroom actually only equates to about 2% of their overall time. Now, I am doing this a little bit hyperbolically. I know that there's going to be time for sleeping and eating here. However, I hope that I'm stressing the point that very, very little time students are actually spending in our classroom, where we spend so much time thinking about pedagogy and interventions and our interactions with students, and we're thinking in cubiculum rather than thinking about students and their holistic academic days or semesters. And in your minds, you might be countering me at the moment, going, well, Sam, there have been plenty of studies out there that show that doing something in the classroom actually has effects. What we're doing in the classroom with new interventions and new pedagogies and things like that, there's research out there. It shows it has an effect. And I agree with you, because in this book by John Hattie from 2009, roughly 10 years ago, it's a fantastic book where he synthesizes about 800 meta-analyses relating to achievement. He says that, indeed, almost everything works. 90% of all effect sizes in education are positive. When teachers claim that they are having a positive effect on achievement, or when a policy improves achievement, this is almost a trivial claim. Virtually everything works. One only needs to have a pulse, and we can improve in achievement. And so Hattie's point with all of that is actually that having a benchmark of having an effect size greater than 0 might be a pretty low bar to set for our classrooms, especially when those relatively low effect sizes, after the excitement has worn off about a particular intervention, tends to go away. He makes a point of saying that, well, maybe we should aim a little bit higher. Maybe an effect size of Cohen's d of about 0.4 might be a good benchmark. So I bring that in just to acknowledge the fact that certainly a lot of research says that the things we do in our classroom have some type of effect. I think Hattie would argue that if we raise the benchmark with that, we might find that less of that is true. So, to the point that I wish to bring here, instead of just thinking about things in cubiculum, I like to advocate for thinking about students spending actually most of their time negotiating a very complex resource ecology that they are immersed in outside of our classrooms. And this resource ecology could be aligned with the courses that we're teaching and could be completely random. That's not something that we necessarily know, although I agree that we should probably be thinking about that. And so this resource ecology includes, but is not limited to, the textbooks down there at the bottom right-hand corner, things that are textbook-like, like Wikipedia pages or online open source learning tools, which I very much advocate for, but don't necessarily know if my students are looking at them or what they're looking at. Getting homework help online. I saw this advertisement a couple of weeks ago, and it was great. You can literally call in to somebody and have them answer a question. There are YouTube videos like up there at the top left, and maybe our students are actually working together with each other, which would be a pretty good case if that was indeed happening. And so I urge everyone listening to think outside the room and to consider the fact that their students are navigating a complex resource ecology in the midst of you trying to do educational or pedagogical research in your own classroom. And so that's essentially what motivates me to think about things like the textbook and try to understand students' interaction with this entity, this particular resource, who it is serving best, who does it not serve, and even try to understand students' motivations or lack thereof for potentially using this particular resource. And so that's what we'll tackle for the rest of this webinar, the textbook. And so in the course of this, I'll present 3 studies, essentially exploring the use and usefulness of textbooks in introductory chemistry courses. Here in the United States, we would call this general chemistry, but throughout the world, this would be a first-year survey course in introductory chemistry concepts. And so we will look at a psycholinguistic analysis of textbooks and of learning materials in general. We will do we'll talk about an investigation of actually learning from texts, almost treating texts as an intervention, and then some preliminary work on the development of a textbook experience survey. And so we will start with this psycholinguistic analysis of textbooks and of text-based learning materials in general. So if we think about how students can interact with a textbook, there's clearly a lot of features that are available to a student. There are pictures, there are equations, there are worked examples, there are problems, and a lot of this has been looked at in the chemistry education literature up until this point, especially categorizing end-of-chapter problems or looking at the dimensions of representations that occur in textbooks. And so in this particular study, we're going to look at the text itself and essentially imagine a student going to a textbook for as a resource and maybe interacting with that text in order to comprehend it or learn something to do a problem or to study for an exam or something like that. And a student's ability to comprehend that information in the text does not depend only on personal characteristics like their reading ability, for example. It depends a lot on the nature of the text itself. And work by Danielle McNamara and Grazer has identified what they refer to as 5 easeability components. This is sort of a 5-dimensional way to talk about the difficulty of reading a test, very much different from what was pretty standard a couple of decades ago, which was the reading grade level of a particular piece of text. But these easeability components are narrativity, syntactic simplicity, word concreteness, referential cohesion, and deep cohesion. Now I have these color-coded. Narrativity and word concreteness, I argue that the author of the text can't really do much about this necessarily in the context of chemistry. Narrativity being the extent to which the text contains familiar elements to the reader, such as an antagonist or a protagonist, or having that wonderful Shakespearean introduction, climax, and denouement type of reading structure. Well, that's probably not going to be there in a resource type of general chemistry textbook. Maybe we can introduce the big bad wolf within these, but again, that would only be one type of element that goes toward narrativity among quite a bit that a familiar reader would recognize. I also argue that a chemistry author can't do much with word concreteness, which is the degree to which the discourse at play contains abstract ideas. We chemists live in an imaginary world where we represent things rather than knowing exactly what they look like. And so our language and our text is also quite abstract. And so I argue that word concreteness is probably going to be quite low for chemistry text, no matter what you try to do. However, the three in blue, I think we can leverage with regard to authoring texts. And that will be syntactic simplicity, the degree to which shorter, the degree to which shorter familiar sentence structures are used. And then the two types of cohesion. Referential cohesion is more along the lines of how different ideas are related on the page, the extent to which the text contains words and ideas that overlap and connect ideas for the reader in a space type of arrangement. Deep cohesion goes more to causal, intentional, or temporal connectives rather than simply arranging things on a page to be connected with one another. And I put stars by the two cohesions because there's something else to know about these two particular easeability components. And that is that they actually interact with student characteristics. And they're the only two that have been shown by McNamara's work in order to do that. And how I mean interact is that they're going to interact with students differentially based on a particular characteristic that those students have. And that will be their prior domain knowledge with regard to what they are reading. And in this case, it would be their prior chemistry knowledge coming into a general chemistry course. And so it's been shown quite robustly that students with low prior knowledge are going to benefit from more cohesive texts. And this is because students with low domain knowledge will lack any type of basis to infer information that's not explicitly related in the text. And so those connectives within the text, either, again, in space, on the page, or through causal or temporal types of connectives, are going to connect very pieces of important information for students of low domain knowledge because they're not necessarily going to have the prior knowledge to make those all connect themselves. Unfortunately, that's not the end of this interaction story because a reverse cohesion effect also is at play. Students with high domain knowledge are actually going to benefit more from lower cohesion texts. When students with high domain knowledge interact with highly cohesive texts, essentially the author of that text is doing everything that the student wants to do with their own prior knowledge. And because all of these connectives are already made for these higher knowledge students, they process the text far more shallowly than students of lower domain knowledge. And so we get this interesting reverse effect whereby lower domain students benefit from more cohesive texts, whereas students with higher domain knowledge benefit from lower cohesion texts. And so, with regard to moving this into a general chemistry space, we were very interested in whether general chemistry texts are more or less suited to lower knowledge students. Students definitely come into our general chemistry courses with a wide range of chemistry domain knowledge. And we wanted to parse out whether the textbooks we're giving them for a resource are in any way aligned with that variety, or if they are more suited to one set of students or another. So back when the study was done, we were able to get information from textbook publishing companies, and we identified the 5 best-selling general chemistry textbooks in the United States market in 2012. And these were Brown, LeMay, Burston, Murphy, and Woodward's Chemistry, the Central Science, Chang's Chemistry, Silverberg's Molecular Nature of Matter and Change, Navaldo-Tro's Chemistry, a Molecular Approach, and the Zumdahl's Chemistry 9th edition. And if I remember correctly, these books captured more than 50% of the market in total. So we were getting a good swath of what general chemistry students nationwide were looking at. That said, all of these textbooks were very traditional curricula. You probably all know what I mean when chapter 15 and every single one of them is the same topic. There was no different curricula here. There were no atoms first. There was no clue from Melanie Cooper's group, and so on and so forth. These were all very, very traditional chemistry textbooks. And so from each text, we chose 4 passages at random from each of the first 10 chapters, and they were about 450 words each. Passages were sorted so that they mainly contained text and not equations or mathematical manipulations, simply because those would not be recognized by the computational software that we used, which is known as Cometrics and was developed by McNamara and Grazer once again. This program spits out percentiles of how the texts being analyzed relate to other texts in the database of this program. And anytime a new text is analyzed, that goes into the database of the program. And so that percentile is a relatively meaningless number with regard to thinking about it in terms of a chemistry book. And so we wanted to get calibrated to what these numbers meant. And so in order to do that, we chose 2 of the New York Times best-selling novels at the time because, well, I think people have a good idea of the structure of a novel, and we certainly can look at these easeability components with regard to a novel and maybe understand their relative values a little bit more. And it just so happens that the 2 best-selling novels at that time were Inferno by Dan Brown and 50 Shades of Grey. The undergraduate who helped us code all of this was forever changed by this research project. And so off the bat, here are the 5 easeability components pooled for our general chemistry texts. And as you can see, although there's quite a lot of variability with each of them, they all center around perhaps what we would expect with regard to narrativity and word concreteness, 2 things that I mentioned earlier that, given our discipline, we would expect to be quite low. Syntactic simplicity ends up being relatively in the middle of the texts that were analyzed by this program. But was actually surprising to us was how high the cohesions were in our general chemistry text. And so the answer to the question at the top of this slide is that, well, preliminarily, yes, in general, the cohesion in these books is relatively high. And so we might expect them to be more useful to lower knowledge students than higher knowledge students. But we can go a little bit deeper here. And this slide, although relatively heavy with some statistics, simply compares what we get for the novels versus what we get for the chemistry textbooks. And so all differences noted are statistically significant. And so you can see there's an incredibly large effect between the novel and our chemistry books for narrativity, as we would expect. For syntactic simplicity, the effect is not as big, but still a statistically significant difference. Word concreteness, as we would expect, chemistry is relatively low. But I was very struck with regard to how cohesive our textbooks are relative to novels. This is a large effect size. And although this is just me musing about these data, this might be why reading a novel is a lot more interesting than a chemistry book. It's not necessarily the content, it's how that content is presented. The novels may let us come to our own conclusions about some things. They don't spell everything out for us. That's maybe what we enjoy about a novel, whereas the numbers coming from our chemistry text are more aligned with referential and deep connectives being made. We looked further into this cohesion to try to understand whether among the 5 best-selling books out there, if instructors had the ability to choose one that might be better suited to their class of students. For example, you could give maybe a prior knowledge assessment at the beginning of your class and go, oh, okay, I have some well-prepared students, so I'm going to give them a relatively less cohesive text than maybe if you had a situation where you had relatively high knowledge students. However, among these five, there's very little difference with respect to our two cohesive measures. In deep cohesion, all of these numbers have no significant differences between them. With regard to referential cohesion, Chang is different than Silberberg and Tro, and that is the only major difference uncovered by the non-parametric tests that we ran. And so there is very little leeway here in the textbook market with regard to finding one that is potentially suitable for different levels of students. And so with that, we were able to conclude that the best-selling general chemistry textbooks in the United States, at least, are very similar with regard to readability. And given their high, excuse me for the typo, levels of referential and deep cohesion, these general chemistry textbooks appear to be better suited to lower knowledge students. However, I must admit that we don't have a very good calibration curve for this. We don't know how low is with regard to these measures, and we don't know how high is. And so more work definitely needs to be done with regard to what types of students can learn from what type of text. But that's what we'll get into next after Michael surveys everyone for a couple of questions.
Yes, great. Thank you very much. So there are some questions coming in. Just in terms of general context, so for example, in the UK, we have textbooks. We may incidentally or not refer students to them. So, but as I understand it, in the US system, a lecture course would very closely follow a textbook. I suppose I'm just interested in how useful is it for a student to align with a textbook?
I think that will vary from 0 to 100 depending on the instructor and the course. I know of some instructors who very closely follow the outline of a book and go some extra steps perhaps to engage their students in using that book by asking them reading questions and things like that. There have been a couple of, I believe there was a Journal of Research and Science teaching article about using reading questions and things like that in order to engage students in reading. Or on the other hand, the instructor can be, yeah, here's the textbook, you can buy it if you want.
Yeah, okay.
Right, and so probably the same as your experience in the UK.
Yeah. In relation to this, we don't know how high is. Dawn is a good question, I think, which follows on from that, which is, did you think about other technical texts, for example, other disciplines, or somebody else I think suggested a scientific journal, or looking at more advanced textbooks to try and get a sense of not necessarily a novel but another technical text? Would that be another way of trying to get a sense of this ceiling, this low and high value?
That's a great question. No, we didn't think of that at the time. And I think a corollary to that is actually, well, given the system, right, wouldn't the system be biased to whatever text it had analyzed previously? And so Cometrics was designed with a lot of biology texts, actually. And so there is an implicit assumption that the numbers that we're getting are, in fact, also relative to some other science types of texts. But that said, we did not do particular comparisons with other chemistry subdisciplines or other sciences or Journal of Inorganic Chemistry articles. But that's a really, really fascinating idea to see, yeah, to get a sense more of what these numbers mean, sure.
Yeah. And the audience are full of suggestions. Another idea would be, these Bill Bryson type books, where there is a very strong narrative, but a lot of, anyway. Yeah, it's fascinating. I think there's a lot of interest in that, but I'm going to let you continue, not take up too much time at this point, and please do continue with the presentation.
Good deal. And I will say, with everyone making the great suggestions in the text box here, Cometrics is a free system to use online. You can analyze whatever you would like, whenever you would like, and including the textbook, that you use if you don't use one of those fives. And so it's a freeware resource that, if you're interested, we can certainly help you learn how to use. But now we're going to move on to try to get an answer, a more empirical answer to that question of how low is low and how high is high, by looking at an investigation of student learning from actual texts. And so what we did here was, we're going to have students read from texts and see if we can measure any increase in their understanding or their, in general, learning from these types of resources. And so our study began as follows. We created two types of text, or two texts of two different contents, and that'll be apparent why we chose these particular ones in a second. But we chose bonding representations and we chose redox concepts. And instead of pulling content from textbooks, we actually created our own text, because we wanted to use the very rich literature on misconceptions and alternative conceptions about these topics from the literature to make sure that we were addressing those within the text that we wrote. And then we actually, this graphic is a little bit misleading, but we actually went through a pretty good iterative cycle with Cometrics, so that the finished texts were actually, they possessed characteristics that were within one standard deviation of our popular chemistry textbooks. And so we use this as a model, if you will, for what a student might have as a reference if they're going to their own general chemistry book, at least those that are of the top 5 selling in the United States. And then we did a really, well, I say we, this was my former student Renee Buell, did amazing work on this. She did the following pre-test, post-test experimental design. We chose bonding representation and redox concepts because Stacey Lowry Bretz's group and her former students, Allie Brandwright and Cindy Luxford, put together these wonderful concept inventories that are available for use. And so we didn't want to independently create knowledge assessments and essentially go through revalidating all of that. So we used what was in the literature, and we aligned our study in that way. We also measured their language ability using something called the Gates-McGinnity reading test to ensure that we were controlling for all of the variables with regard to learning from text. So we pre-tested concepts, and then we measured language ability, and then we did an intervention. And that intervention was simply reading a text related or unrelated to the topic. I believe the unrelated texts were something about loons, and they were something about mushrooms. And then we post-tested the concepts using the BRI or the ROCSI 4 weeks after the pre-test, so that there was no danger necessarily of remembering what that test was about, and then approximately 3 hours after the intervention. We did this in the lab sections of large general chemistry courses. And so the students would read a text at the beginning lab. They would do a lab experiment that was never really related to what the text was about, especially if they got mushrooms. And then they took the post-test at the end of that lab section. And so we used 2 different types of courses to do this. And one was a traditional, in the United States anyway, 2-semester sequence of general chemistry. I denote those A and C here. And 2 accelerated 1-semester courses, which are denoted B and D here. And here's the number of students that we dealt with. A and D dealt with redox concepts, and B and C dealt with bonding representations. And the study was done before instruction with regard to any of these concepts. Okay, so here's what happened. So here I have our four courses and the concept inventory that was the content of these classes. And on the left, I have the factors that were put into the regression models to try to figure out what was going on here. And it was whether they read a related text or not, their pre-test score, because prior knowledge is going to impact not only how they read that text, but also how they're going to do on that final knowledge assessment, their language comprehension, and then various interaction terms amongst the three main variables. So here we go. In course, here is the statistical significance of various levels of things that resulted from each of these studies. And as you can see, it is all over the place. There was not one set of variables that was statistically significant in all 4 of our trials of this, which was maddening and is perfectly acceptable for the Journal of Irreducible Results. So this is a worst nightmare, right, for a researcher, but it's also a pretty good reason to always repeat experiments that you do, because you never know how the environment of that experiment might change the results. But fortunately, there is something that we can do, and that is create a meta-analysis on each of those 4 studies, and essentially look at the effects of all of these things in concert, so that we can pull out some overall patterns of what's going on. And that's what this chart does for us here. At the top, we have the first 4 lines essentially represent the mean, Pearson's R, and the confidence interval of those effects for courses A, B, C, and D. And then the circle, this is very hard to do without a laser pointer, but this circle right here represents the weighted average, the population weighted average of those effects. And so you can see that reading a text that was related to the topic only had a very mild effect, which is quite interesting. For reading skill, also a very mild effect with regard to what's being averaged over the four studies. Prior knowledge had the greatest effect. And then the reading, a related text and prior knowledge interaction term also had a notable effect, but it was negative in nature. And what this means is that reading a related text had more of an effect for students of lower prior knowledge. All right, and so the next slide summarizes this a little bit more. Now, the plots that you're looking at are not real data. They are simply a way to sort of look at this effect. And so what these represent are the pooled data for all of the students who took this, who did this experiment, with the bonding representations inventory on the top, and then the redox concept inventory on the bottom. But hopefully you can see here, and how these plots were made were simply by plotting out the regression equations that we get from our statistical models of these data. What you can see is, if you look at low prior knowledge, so to the left of these x-axes, this is the pretest score. We see that those that did read the bonding text ended up performing better on the post-test than did those who didn't read the bonding text or didn't read the Roxy text. All right, makes sense. You read something, you don't know very much about it, you're going to do better later. But it reverses at the higher end. And so students who had a very high prior knowledge, all right, according to our models, were actually scoring lower than students in the control group. Or excuse me, students who read the text and had higher prior knowledge were scoring lower than those who read the control text. And this goes back to how prior knowledge and reading comprehension sort of go hand in hand. This is known in the literature as an expertise reversal effect. Students of lower prior knowledge with these particular texts appear to have more of an advantage using them as a resource than students with higher prior knowledge. And so if we're using these texts as a model of what's going on in our general chemistry books, students with higher prior knowledge may not necessarily want to use those general chemistry books as a resource, because at least in our model studies, they're not gaining the effect that lower prior knowledge students are. We followed all of this up because, well, these field studies were very, very dirty, and you could even see that the confidence intervals around those previous effects were quite large. And so we did one more study that was a lot more controlled. We took another entire class of students and gave them the bonding representations inventory, and then invited only those students who scored below average on the pretest to participate in this study. And we did it in a controlled room in which they read a text, and then they ate some pizza and had some conversations, and then they took the post-test. And so here I show you the results of that. That for these students, those that read a text about loons really had absolutely no difference between their pretest and their post-test score. And that was not a statistically significant difference. However, those that read a text about bonding, all right, what the BRI was all about, they had a very nice shift in their overall scores from pre-test to post-test that was a significant difference. And so if we're targeting those low knowledge students in a controlled way, reading the text about bonding showed a very nice effect. And we can get it even a little fancier and perform a regression here to see that whether that text was read or not, based on controlling for other variables, including prior knowledge and reading comprehension and things like that, still ends up with a very, very large effect. The partial R here equates to a large effect. So does the interaction between reading and pretest score, interestingly enough. But you'll notice here that now this is positive rather than negative. And so we explain this by the fact that we're now in having a population with such low prior knowledge that what you do know is actually important and allows you to read the text to a greater extent. It's only when you start pushing into really higher prior knowledge that we saw in the previous set of studies that you begin to have a disadvantage. This last interaction, although statistically significant, did not have an effect size that was really worth talking about, so I won't. And so in summary, with regard to this idea of who can learn from general chemistry texts, I hope I've given you some information about how our texts can actually interact with readers in different ways. Certain students may be able to learn better from more cohesive texts, while others learn from less cohesive texts. And I already mentioned the fact that our general chemistry texts aren't very different from one another, and so is there an opportunity to help those students with differing levels of chemistry knowledge? And with our preliminary work, we're seeing that, well, yes, if you're low enough in prior knowledge, those texts will help you. But in our more field types of studies, we are seeing a reverse cohesive effect, or a reverse expertise effect, in which students of higher prior knowledge are likely not engaging in those texts in a very deep way and are not using them as a resource is a little bit of a disadvantage. They could probably use a better one with their time. But that also brings up a question of, well, do students actually use the textbook at all? We're doing all of this, well, what we think is very nice work, but are they even using this as a resource? And so I'll just spend our last couple of minutes here telling you about the fact that we've thought about this and we're developing a textbook experience survey. And so previous work has definitely investigated features of the textbook. For example, Talankar and Davila wrote this great article saying that the end of chapter questions don't really leverage higher order cognitive thinking very much. And so, you know, if we want our students to go in that direction, we have to provide them for ourselves or change the textbooks. There's also been commentary as well as empirical work on how textbooks can be improved. The article there from the Asia Pacific Education Review, whose names I am not going to try to say, apologies, came up with this idea to actually, this wonderful idea, to structure a textbook on constructivism. Who knew that would be a good idea? And so our big question, though, is how do students interact with the textbook, and what are their motivations for doing so? There seemed to be space in this area to do some work. And we wanted some specific goals for this textbook experience survey. There had been others in the literature, but our main critique of them was that they were a very end of semester reflective time average experience. And so I don't know about you, but I can't remember what I ate yesterday versus how often I used the textbook over the past 6 months. And so we adopted experience sampling for our particular survey method, in which students are surveyed multiple times in a semester and actually only asked to think about how they use the textbook in the past day or the past week, so that that information is a little bit more accurate. We also wanted to tap into some expectancy value theories of motivation, which in a nutshell says that the behavior depends on one's expectancy for attaining a certain outcome and then how much one values that outcome. And we wanted to layer this on whether they are finding textbooks as motivation to do well in courses and how they value that outcome, as well as using a textbook in regard to achieving that outcome. We wanted to use terminology and ideas that are credible to general chemistry students, essentially ensuring internal validity of the survey. And so we used a methodology whereby we interviewed students so that we were using how they talked about things in order to make sure we were accurate in what we were surveying. And then getting back to what I was saying before, we definitely wanted to place textbook experiences in the context of the broader ecology of resources, again, to try to look at how students are valuing their experiences with textbooks in the broader ecology, rather than just considering the textbooks in cubiculum. And so here is how Renee put this all together. It was essentially a 4-stage development process that was sequential mixed methods. And it was a lot of fantastic work. First, she started out with open-ended interviews of students with regard to these questions like, how did you decide whether to buy a textbook? When do you use a textbook? What parts of the textbook do you use most often? What do you call different features of a textbook, so on and so forth, in order to get students language about how we could develop a more quantitative survey initially. But that first quantitative survey actually had some qualitative aspects to it with regard to some free response and multiple choice questions that went through multiple rounds of coding in order to shape those free response questions into more multiple choice questions, as well as take out redundancy within the survey. And eventually she got to developing a final survey that we have collected data on. However, I will say right now that we're not finished analyzing said data. So what I have to share for you with regard to the overall question of, well, we're spending all of this time thinking about how students are interacting with textbooks and learning from them, and, well, do they use them? And probably unsurprisingly, the answer is not really, within the greater ecology of resources available to students. And so here's a simple frequency plot of a set of data that we collected approximately a year ago. And as you can see, textbook is in orange. Problems from the textbook is light blue. A student study guide, which is actually used in our general chemistry courses and students identified independently as a resource, is used in here. And you can see internet sources in yellow, online homework, so on and so forth. We can see that very frequently students are using notes that they wrote or slides from the professor or notes from the professor. Students are not using the textbook very frequently at all. In fact, they are reporting using it very rarely. Almost the rarely and the very frequently sides of this are mirror images of one another. Now, why this is happening, we're not sure yet. And we would love to get into our pieces of data that really speak to the motivations of why this is happening. So stay tuned for a future article or another webinar if Michael even decides to invite me back anytime in the obscene future. So to sort of wrap up here, with regard to the use and usefulness of chemistry's most ubiquitous resource. Preliminarily, we are observing that students report using other resources way more frequently than textbooks. Why? Well, we're still crunching the data. The text of a textbook may only be useful to certain subgroups of students, i.e. those of low domain knowledge. Are there other options? Not really. Gen Chem books tend to be particularly similar. And then my last point here is that, well, are we even surprised by any of this? I like to argue that textbooks usually aren't written for students. They're written for the reviewers who are faculty, because that's the only way a publishing company is probably going to publish them, is if expert reviewers say that they're good, and expert reviewers are going to say that they're good if they look like the textbook that they wrote. So I'm not particularly surprised by any of these larger conclusions that we have. However, I'm very happy that we're able to put these data forward. And so with that, I'm sure there are going to be some awesome questions and discussion happening. So thank you very much for listening in.
Thank you very much, Sam. A lovely scope of work that you've presented. There are lots of questions coming in. Can I just dive in immediately with a practice-based question? This thing about the level of prior knowledge is sort of slightly disturbing me. I'm sort of a bit worried about recommending textbooks to students. And I'm just wondering, do you have any sense of perhaps how we might instruct students at different, well, levels is the wrong word, but how we might know perhaps how to guide a student to use a textbook? So, for example, I might tell somebody who hasn't a clue, just go and read the chapter. I might tell somebody who knows quite a lot something. I'm not quite sure what, but so in other words, starting to think about how we teach students to interact with textbooks more. But I'm sorry, as you can see, my question isn't well formed. But
I think I know where you're getting at, though. And so there is a great swath of literature on essentially learning how to read and how we can get students to overcome perhaps individual characteristics that they might have. And a very strong effect are reading questions. And so pairing questions, either open-ended questions or multiple choice questions or things like this, with a reading assignment so that the students with low reading skill or who might have lower domain knowledge know what to look for in the text. Those questions can sort of act as a guide for them about what to pay attention to and what not to. Not every word is important, and that also takes a fair amount of domain knowledge to actually negotiate. And so there are very strong effects with regard to these types of reading questions. That said, unless those are given credit in a course, students may or may not be using them, right? And so I think the instructor needs to weigh that quite well. Do I give my students reading questions and just let them on their own uses, or do I assign them and keep students engaged in the book throughout the semester by giving them points for answering these questions or things like that? That'll be up to instructor discretion, but there is a lot of literature with regard to that particular technique.
Okay. I'm going to skip back to your slide 28. I'm just conscious of time, but could you just elaborate on this? There was a question about this again, just this issue of prior knowledge and low and high performance. Maybe you could just hit the top graph and just go through that graph again.
Yeah. I probably spent too much time going, these are just models. Don't take this without a lot of salt, right? Because I truly mean it. We need a lot more research to bear this out. But the idea is that on our x-axis, we have pre-test score, which was given 4 weeks before the post-test score. And here essentially is the intervention. Either they read a text about what the test was about, or they read a text about mushrooms or loons. And so when a student has a low prior knowledge, all right, reading the text gave a better score on the post-test than not reading the text. And so that bit is probably unsurprising. But shifting up to the higher levels of prior knowledge, and this is all z-scores, and so this is standard deviations of the class at play, we are seeing that students who read the text at this level of prior knowledge are actually projected to score a little bit lower than students who read a text about loons or whatever. And so this is the reverse expertisal effect.
Yeah.
Now, again, it's just a model. The real data are probably saying that there's no difference between these points. But rather than showing a scatter plot, I'm showing regression equations.
Great. The questions are coming in thick and fast, so I'll do my best. The frequency data, Flynn Research Group, how did you account for the possibility that some students didn't purchase textbooks?
We actually did account for that. There was a separate question in the survey that asked, did you purchase a textbook? And if you did, what options did you pursue? And from the students, we were actually very surprised at the things that they did. And so they could, some of the prompts were, I purchased an online textbook. I purchased an online textbook because it came with my online homework. I used generally an external website to the course and things like that. And so these data that I'm showing here are only those students who reported purchasing a textbook.
Great. And then John Moore, I assume it's the same John Moore who knows a lot of textbooks. Textbooks is more than text in textbooks, obviously, so textbooks have figures. So are you solely focusing on the text and the narrative, or is there a consideration about the role of figures and other aspects of textbooks in this study, in these kind of studies?
As of right now, we've only focused on the text. We're hoping to get some information from this survey with regard to, well, if students are paying attention to the text, where are they showing their focus? Are they taking a deep dive into figures, or are they treating them very shallowly? And so once we have information from that, we can connect that back to all of the good literature on representations in textbooks. But at the moment, we haven't done anything except look at the text itself.
Okay. An invitation to talk at Meister, so I should say Sam will be in Edinburgh in a few weeks' time. We're very excited. So Jenny, you'll be able to talk to him there. But that question, your other question is who sets the exam? So obviously, if a lecturer sets the exam, perhaps what they say about textbooks might be more important. Or is there something with the ACS versus the again, sorry, I'm ignorant of the international audience because I don't know either. Who actually sets the end of year exam that the students do, or how does the assessment work, and how does that relate to the textbook?
Sure. And so at my institution, the instructors set the exam. Sometimes an American Chemical Society exam is used for the final. However, I do have to note, I'm sorry I'm not actually showing you the survey. It didn't really occur to me to do that for some reason. But in the process of talking to students about the language that they're using and expectancy value and things like that, a student actually said, well, I don't use the textbook because my instructor doesn't seem to value it. I'm paraphrasing, right? And so we actually included something on the survey, to what extent does my instructor seem to value the use of the textbook? And so again, we're still crunching data, but it'll be very interesting to see if that is a predictor of how students actually interact and experience the textbook. So again, sorry, don't have the answers yet, but hopefully they're coming soon.
Interesting though, yeah, because I think that student get a very strong message from instructors. Certainly here we noticed that if an instructor puts a textbook reference on their slide, for example, it gets very kind of high attention, whereas if it's just, I'll go and read this chapter, it tends not to, so it's interesting.
Sure. So
Stacey asked, but it's a more general question, I think, around this. You sort of hinted at the end that perhaps we write textbooks for each other, perhaps better than students in general. What kind of recommendations would you make based on the kind of things you're observing from your work about writing textbooks?
So perhaps I came off too strongly. I have never written a textbook myself, too. So respect to all those in the audience that have. I don't know how publishing companies actually deal with this either. But I think it will be phenomenal if but I have been invited a lot to focus groups of publishing companies to look at different sections of books. And I've gone and I've looked around the room and I've seen only faculty members. So why don't we do student focus groups with these textbooks and give them sections to read and see what they can recall from those sections, and if we're seeing understanding being achieved, or how students are interacting with that book. I think we can learn a lot from watching our students interact with it rather than simply faculty. Some companies might be doing this. I apologize if I'm making grand assumptions based off my own experience.
Yeah, but I think you hinted earlier about that study that did the constructivism-based approach, and I guess that would probably be the first sort of general guidance, wouldn't it? But certainly from your own work. But anyway, sorry, I'm rambling, and I will just say thank you very much to you, Sam, for a really fantastic seminar on something that is core to our chemistry teaching and a ubiquitous resource. And thank you for your insight and information. I look forward to following up those studies and the many references on your presentation. I think they'll be very useful. Stacey asked the last question, and I'm delighted to say Stacey will be the next speaker, the final speaker in this series. We've really had a fantastic run this year with lots of amazing speakers. So I welcome you to join us for Stacey's talk on the 22nd of May. But will you please just join me in virtually applauding around the world. Flowers on stage, everybody, for the wonderful Sam. And thank you very much for your fantastic talk.
Always my pleasure. Thank you all so much.